Hey, my mad peeps, what's happening? Today we're going to look at multiplying and dealing with the powers of I. And here's why. Here's why we have to know about the powers. So last video we added and subtracted, and you saw me slip up and kind of give you a hint about the calculator for multiplying, which is fine. But here's the reason why we have to know about I's and like their higher powers. Because since I always say that they're just like X's, you can do something like this, right? And you're going to have x squared plus 3x. Okay, or we can get crazy and you have like x to the fifth times x squared plus 4. What do you have now? X to the seventh plus 4x to the fifth. So in using expressions like x's and y's, who cares? That's fine. You can have x to the seventh, and what does that mean? It means you can put a value in there, like 13 or 17 or something. X's are just placeholders for value. But when you're talking about i's, we already know that i's have values. They're not just placeholders. They're actually something. So all of these numbers here actually can be reduced or changed. And what do we know most fundamentally? It's this, that I is the square root of -1. So when we start multiplying today, we first have to just take a break and say, wait a minute. When I multiply i's, I'm going to add their exponents, just like x's. If my exponents get huge, shouldn't I do something? And the answer is yes. So we need to define these four values here, and then you'll realize that there are no other possible answers besides these four values here. And then I'll give you the pro tip in the calculator, and you'll be set to go, and we're going to be ready to multiply. Okay, so here are some fundamental things you need to realize. I, if you have a zero exponent, in fact, anything with a zero exponent is 1. Anything to the first power is what it is, right? So check this out. You're halfway through and it was already so super easy. Now, I squared. Well, most of you kind of recall that when you square a radical, the radical goes away. I squared is just whatever's under here, -1. Now, I to the third, that's going to be -I. Why is that? I mean, I think the first three are self-explanatory, wouldn't you say? But what's with I to the third? How come it's just -I? I want you to think about it this way, especially for what I'm about to say. I to the third as being I squared times another I, right? That would give you I to the third. But now do a look back and say, hey, wait a minute. I know what this guy is. I've already figured out I squared. I squared is -1. So if I multiply that by another I just have -1I, right? That's all. Now keep that train of thought going. Let's go down here to I to the fourth. I to the fourth is just going to be I to the third times another I. And wouldn't you know, I to the third is -I. And if you multiply that by I, you get -I squared. But you know I squared is -1. So negative of a -1 is +1. Go to I to the fifth. I to the fifth is I to the fourth times another I. What's I to the fourth? It's 1. We already know that. If we multiply 1 times another I, we get another I. I'm going to stop soon. I know you're freaking out right now because this is Ed Puzzle and you can't fast forward. I'm not going to go on forever, I promise. I to the sixth. So, that's going to be I to the fifth times another I. I to the fifth is I. I times I is I squared, which is, again, we look back, I squared is -1. Really cool. Last but not least, I to the seventh. I to the seventh would be I to the sixth times another I. I to the sixth is -1. -1 times I is -I. All right, I'm done torturing you. Now watch. This pattern goes on forever and ever, and whoa, where are you going? There we go. A little more. Very cool. Okay, it goes on and on and on like this. There's only 4 possible answers. So watch, I don't even have to know what I'm looking at. I just know that this is 1, this is I, this is -1, -I. And again, 1, I, -1, -I, 1, I, -1, -I. It just keeps going around in a circle. We used to call it the I clock. And you might ask yourself now, well, I don't want to build this chart if I have to get to like 79 and keep doing this pattern. It's a little ridiculous. So here's the algebra, and then I'll show you the calculator. But I do need you to know this, okay? Since there's only 4 possible solutions, the shortcut for finding out which I'm going to have is to take this crazy exponent and just divide it by 4. And whatever your solution is, the remainder, that's your new exponent. So watch. If I have 34, I'm going to do this. 34 divided by 4. I think that's 8. 8 times 4 is 32. 2. I'm done. Nothing to bring down, right? So what's my answer to 34 divided by 4? It's 8 remainder 2. This, my friends, is the money shot right here. That's the guy we're going to use. So what we say is I to the 34th is equivalent to I to the 2nd. Because there's only 4 possible values. We just saw that. It just keeps spinning around and spinning around. So to get a shortcut, you just divide the 34 by 4, and the remainder turns out to be your new thing, your new exponent. Now, what is this? -1. So what does that tell us? I to the 34th is -1. All right. I hear you guys screaming. Let's go to the calculator. Let's see how this works in the calculator. It's so cool. I part is what I'd like you to do. I part. So let's do math, number, I part, number 3. Throw in there whatever you want. So watch, I to the 34th. I is the decimal, caret 34. Hit enter, boom, -1. What's I to the 35th? If we know our little wheel, we know it's supposed to be -I. Pretty cool. This will do anything. Last one, I'm not going to go on for days. Pick a number, 892. I don't know, something crazy like that. Bam, it's 1. So I part could really be your friend in the calculator when we're multiplying complex numbers and our i's start to take on these higher exponents. It's a really, really cool tool, but I do need you to know the theory behind it. Okay, so let's move on. These guys here, I to the 28th. I could either use the calculator or divide by 4 and use the remainder. So what's the remainder? Nothing. 7, right? 7 goes into 28 evenly. So I to the 0, that's going to be 1. So the rest of these I would like you to do, because as you can see, they'll take literally 2 minutes. Now this is where the action gets a little bit hairy. How do we multiply these i's now and then reduce them at the ends? So let's take a look at number 1. If you remember PEMDAS and the loyalty of the exponent, which has no side bays, unless it's holding a briefcase, which this exponent number 3 is doing. So if this 3 is attached to this briefcase, I need you to do this. I want you to apply that exponent to everything that's in there. So this is like saying 3 times 2 to the 3rd power, and then I squared to the 3rd power, which is 3 times 2, 6. Nice. Let's simplify. 3 times 8 I to the 6th. Let's distribute. 24 I to the 6th. Now nobody does this. Again, no one's coming around with the hors d'oeuvre platter with the scallops wrapped in bacon if you're at the dinner party because you're saying that the answer is 24I6. No way. We need to now reduce these, and you know how. Either use your calculator or do the divide by 4 and whatever your remainder is business. So I know that this is going to be equivalent to 24 I squared. I squared is -1 So the answer is negative 24. But look at this thing in red. Give it to me in a plus bi form. You remember from the last video that every number can be written as a complex number. You just have to give it a 0 I. Cool. So we're going to distribute this twice, right? That's what it means to square a binomial. So the math is as follows. 2 times 2 is 4, minus 6i, minus 6i, and the last guy is going to be plus 9i squared. Combining like terms, look at what we have. However, we now know what I squared is. It's negative 1. So we don't leave that laying around. We don't leave i's laying around with exponents. We simplify them. So I squared is negative 1. So 4 minus 12i plus 9 times negative 1. So that's really 4 minus 12i minus 9. Combining like terms, 4 minus 9 is negative 5 minus 12i. Here is your a, and here is your bi. Gorgeous. And look, it's a minus. Remember I said it doesn't have to be a plus bi. It just turns out that the b is a negative number. Cool.
Oh my god, where is he? Oh my god, don't kill me! Y'all got the Wi-Fi password? No. Okay.
Hey, do you want to be Frozone for Halloween?
Frozone? I look nothing like Frozone.
Yeah, that's a dumb idea.
Oh, come on!
Now, if we go back to our calculator, check this out. Parentheses, what were we dealing with? 2 minus 3i squared, 2 minus 3i squared, and look how fast your answer comes up. Negative 5 minus 12i, negative 5 minus 12i. Beautiful. Now, this idea of conjugate before we leave, conjugate. This is really important when it comes to our roots, when we're finding solutions to quadratic equations and when we're talking about the potential number of real roots and complex roots. The idea of conjugate is going to be very key. So what a conjugate really is here would be changing this sign and nothing more. So if you want to multiply 2 minus 7i by its conjugate, you multiply it by 2 plus 7i. And then you're done. We're out of here. Let's use our calculator. 2 minus 7i, 2 plus 7i. Look good? Yeah. 53. Where'd that come from? This is awesome. Check this out. I just wanted to show you the answer real quick in the calculator. And now, the idea of conjugates, just like difference of two squares, it's really cool. The middle terms end up disappearing. Watch. 2 times 2 is 4, plus 14i, minus 14i, minus 79i squared. Ladies and gentlemen, I squared is negative 1. You know that. So what do we have? We have this. Bye-bye to you. You're canceling each other out, leaving us with 4 minus 79 times negative 1. So basically this sign will always end up getting flipped if you're attached to an I squared. You'll get to know that pattern as you practice more. So it really is this. Oh, Murray, you're an idiot. That's a 49. Whoever was yelling at me first, I give you a Jolly Rancher tomorrow. So, sorry, that's 49. I don't know where 79 came from. 4 plus 49 is 53. But listen to what I'm about to tell you. I didn't do this on purpose. I did not do this on purpose. But it did help to use the calculator because I knew the answer was this, right? And as I was going through this with you, I'm a little bit nervous because it's live and, you know, just like when I'm standing in front of the class. And when I multiplied 7 times 7, somehow I got 79 because in my head I had the number 7, right? So using your calculator is really, really important and it does help. And, you know, had I left the answer like this, I would have definitely lost 1 or 2 points on a Regents exam. Okay? So anyway, that's why we always give you those pro tips, Miss Sanfini and I, because we love you and we don't want you to lose points because you're nervous. Okay, do I have anything else? I think I do. Let's see, what else do we have? Oh yeah, this guy, then we'll go. So evaluate this expression when I is 3 minus I. Sorry, when x is 3 minus I. So that just means, you know, put that stuff there. So 3 minus I squared minus 6 times 3 minus I. And then evaluate it. Just basically tell me how much it's worth. So I'll do this part first. And then I'm going to do 3 minus I squared in a calculator. Because that's what we do and that's how we roll. Bam, look at that. 8 minus 6i. Don't have to tell me twice. Okay, let's look to combine like terms. The 8 and the 18 I can combine. So this would be negative 10. The 6i, negative by the way, and the negative 6i would be negative 12i. Cool. Now the next one I want you to do on your own for homework, but just to give you a hint, right? You're just plugging that guy into the x's and making sure that it actually equals 0. And if it does, then you're verifying that yes, this is a solution to this. And that's something that we're going to start talking about next time. Okay? Hope you enjoyed the video. Have a great night, and we will see you tomorrow.